Hey everybody, Mr. Piercy here, and what we're going to be getting into with our new unit is going to be segments of triangles. Now, segments of triangles is traditionally something that is quite challenging for geometry students for a couple of reasons. One is that there is a lot of vocabulary associated with this topic. There's going to be several vocabulary words that you probably, most of them aren't familiar to you. And the second thing that makes them very challenging is that each of those vocabulary terms, they have a lot of their own properties associated with them. So not only do you have to know what the words are, but they create certain things and you have to know how to identify them and use their particular properties in context with a problem. So the first one that we're looking at here is called a midsegment. A midsegment is called a midsegment because it connects two midpoints together. Now every triangle always has three midsegments because it has three sides which each contain a midpoint. You may or may not be needing to make more than one midsegment at a time, but the primary things that we need to recognize about a midsegment is that they are going to be parallel to the third side of the triangle, and they will be half the length. So you could look at it one of two ways. You can say, well, the midsegment and the third side of the triangle will be parallel to each other. And the other thing is that either the midsegment is half as long as the third side of the triangle, or you could say that the third side of the triangle is twice as long as the midsegment. So that's what we're looking at here. Oops. I don't know why I'm getting a go away. There we go. There we go. So make sure you have the diagram added to your notes, please. There's a reason why I put these things in the demonstrations. You have to start training yourselves to recognize these things visually in a diagram. So now let's take a look here. Here's a type of example that you could expect to see based off of, in this case, we're talking about properties of a midsegment. So here we have a triangular window and the diagram, we have segment DF and EF, and they're telling us that they're midsegments of triangle ABC. Well, if DF and EF are midsegments, DF and EF, that means that AD and BD have to be congruent to each other, and AF and CF have to be congruent to each other because D and F have to be midpoints if they create a midsegment. So we want to know, well, how long is segment DF? Well, looking at the diagram here, if DF is a midsegment, then it's half the length of the third side of the triangle, or the side that it's parallel to. So therefore, it must be half of 90 inches, and therefore 45. So I'm going to put a 45 here. Uh-oh, announcement time. Sorry about that. They're making announcements over the intercom right now. But so there's DF. Now let's take a look. Well, what about AB? What do I know about AB? Now I'm intentionally kind of ignoring the solution material that's there. I'm just looking at the diagram and thinking my way through it. So here's AB. Well, AB is going to be the third side of another midsegment. EF, it tells you, is a midsegment, so that means that AB is parallel to it, and it must be twice as long. So that means this side must be 90 inches long. So we're looking at this thing here saying that in one case the midsegment is going to be half as long as the third side, but in the other case we're going to take a midsegment and double it to get the length of a side of a triangle. And that's what we're looking at here. So here, at this point, I want you guys to go ahead and think about what we've been talking about with midsegments and how we can use this stuff to work out sides of a triangle or segments of a triangle based on the fact that certain things are parallel and either twice as long or half as long, depending on what you're looking at. So go ahead and pause the video, answer checkpoint question 1, and when you're ready, come on back and see how I did, or check your answer compared to mine. Okay, guys, so hopefully we have a good answer for example 1. So it says consider triangle ADF. What's the length of the midsegment, excuse me, opposite of DF? Well, let me pick another color here, and let's go purple. So what's the length of a midsegment opposite of DF in triangle ADF? Well, a midsegment that's opposite of there is going to be something right here. And since the midsegment has to be half as long, I'm going to take half of 45 and say, oh, where did I type my answer there? There we go. That we would have another midsegment that would be 22.5 inches long in this case. Now looking at example 2, in the diagram at the right, we have QS and SP equal to each other. Well, since they're telling me that, I'm going to go ahead and mark them that way. So QS and SP are equal to each other. So that probably means that point S is going to be a midpoint of segment QP. Now we also know that PT and TR are the same, so PT and TR are the same. So again, point T is very much going to be a midpoint of segment PR. So how do we know QR and ST are parallel to each other? Well, QR and ST, because point S is a midpoint and point T is a midpoint, they're creating a midsegment ST. And according to the midsegment theorem, we're going to say that the midsegment is parallel to the third side of the triangle. So that's really kind of what we're looking at here. I'm just looking at it as a logical reasoning exercise. So because those things are parallel to, or perpendicular, I can't say, because those segments are bisected, we have some midpoints, and therefore we have a midsegment, and therefore the segments are parallel to each other as a result. Okay. Now here we're at checkpoint 2. I want you to go ahead and pause the video and answer the question based on the diagram that you see in example 2. And when you're ready, come back and compare your answer against mine. Okay, so let's see how you did. In example 2, if point V is the midpoint of QR, and I'm going to go ahead and pick another color here so we can get away from the purple. Let's go back to red. So if V is a midpoint of QR, so that means QV and VR are the same. What do you know about SV? Well, if point V is also a midpoint, then segment SV has to be a midsegment and therefore must be parallel to segment PR. So that's how I'm going to kind of explain my answer here. All right, now again, as we're kind of working through these things, if there's something that you're not sure about as far as why I'm saying this is the answer, by all means, make sure you make a note of it to yourself and send it to me in the email, send it to me in the comment section of the classroom, but don't just say, okay, well, let's move on. Make sure you understand why we're doing this. Now, here is going to be something that we will talk about a little bit now, and we may revisit it at some point in the future. But what we're going to be looking at here is generally referred to as a coordinate proof. Now, if you are very much into pure mathematics, this is going to be something that will really appeal to you because you're not going to have to spend, or we're looking at algebra and how it's going to apply to a figure on a coordinate plane, but we're not really associating particular values with the coordinates. We're just picking arbitrary values which we substitute as a variable. Now, because we're picking a variable as opposed to a number to represent coordinate points, we're able to do math with the variables as opposed to numbers and generate proofs, generate rules that would be valid for any figure, not just the one that you see on a piece of paper at any particular moment. So this is a very good exercise for a purely math experience. It's something that people have been doing for years and years and years, but for high school students, this is going to be probably something that's new to you. So looking at the figure here, let's look at figure A. How how are we figuring out the coordinates of these things? Well, S, they're using S, and I'm presuming that they're using S as the variable to represent side of a square, okay? Properties of a square say that all four sides are the same. Now, whenever possible, what we like to do for coordinate proofs like this is we try to use the x and or y axis if we can, using the origin, because using the origin helps simplify things. Also having the x and y axis used also helps simplify things simply because we know the values of those coordinates. If I don't go anywhere up or down, the y coordinate is 0. If I don't go anywhere side to side, the x coordinate is 0. So from the origin, we're going to go to the right some spaces. We don't know how many. That's why we're calling it S. And so we're going to go up the same amount of spaces, which is what's going to give us the point 0s going up. So because I go s spaces to the right and s spaces up, that's what gives me ss as the coordinate here in the top right corner. Now looking at figure B, all right, again, we're utilizing the x-axis and the origin, so we're creating a triangle. And why are we using the points that we have here? Well, from the origin, we're going to go so many spaces to the right. We don't know how many spaces to the right we're going, so they picked the variable b to represent that. Now let's look at the point up top. Let's look at AH. Why is it AH? Well, the reason why it's AH, let me pick a different color here. First of all, I am going to the right so many spaces. But because I'm going to the right of the origin a different number of spaces than I did for this point, we pick a different variable to represent the different length. It didn't have to be A. It could have been anything. But in this case, they chose A. And because I have to go up so many spaces, perhaps they're using the letter H to represent height, but it could have been C's or D or M. It doesn't really make a difference. All we're doing is we're picking some kind of arbitrary variable to represent a length. And of course, different lengths must have different variables. So that's what we're kind of looking at here. Okay. Now, we're going to use these, like I said, just kind of minimally for right now. It may be something that will come up in the future, but for the time being, as we're looking at these coordinates, well, let's see, whenever we go side to side, whatever length it is, pick a variable and call it a letter, whatever letter you want it to be. And if it's a different length side to side or a different length up or down, just make sure you pick different letters to represent different lengths. So here we have a square, and it's the same square that we saw a second ago. And it's telling you to draw it. Well, I mean, it's already done for you. It says, find the length and a midpoint of a diagonal. So what we're going to do is we're going to just add a diagonal into the figure. It doesn't matter if you went vertically with, or if you have going from the origin to B or from A to C. It will work out to be the same either way. Okay. Now keep in mind the distance formulas and the midpoint formulas since we're going to be using them. All right. Now substituting. Now this is what I was referring to when I say this is an exercise in pure math. We're not using numbers. We're using variables to represent these things. And by doing so, we should create rules that would work for any square in this case, not just the square that we're looking at now. So if I want to know the length of the diagonal from point B to point D, taking the coordinates, I'm going to substitute into the distance formula, and I'll get s minus 0 squared plus another s minus 0 squared, the difference of the x's and the difference of the y's. Well, simplifying inside of the radicals is just going to give me s squared plus s squared. So that means those are like terms. Because they're like terms, when I add them together, underneath the square root symbol, I get 2s squared. Now, 2s squared, we're going to try and take the square root of it. 2 is what we would refer to, the way that we classify it in math, is we would call that, the square root of 2 is called an irrational number. And we try to avoid those whenever possible. So if you type the square root of 2 on your calculator, it's going to come back with 1.414, blah, 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 blah. It never stops. Well, so because it's an irrational number, we actually are going to leave it in the form of a square root. However, s squared is also being taken the square root of that. Anytime I square something and take the square root of something at the same time, all we're left with is whatever we squared in the first place. So in this case, I'm going to wind up with s times the square root of 2 to represent the length of the diagonal. Now this is going to be something that you will be seeing later on. Okay, so just keep that in the back of your mind somewhere. But that will be the length of any diagonal of any square. That's how we could figure it out. So now let's take a look at where the coordinate of the midpoint is. So substituting the formula with the coordinates, we're going to say s plus 0 over 2 and s plus 0 over 2 because the x and the y coordinates are just giving us that stuff. So simplifying it, s plus 0 is just s. And so we're going to wind up with just s over 2 and s over 2. So for every square that we ever see, if I want to know the coordinate of its midpoint, I'm going to take the length of the side and divide it by 2 for the x and y coordinates, and that's where we're going to find the midpoint of its diagonal. So now at this point, let's go ahead and take a moment, think about what we're going to be doing here, and read over the questions. And when you're ready, write down your answers, and when you're ready, come back and compare yourself against mine and see what you did. Okay, so here, number 3, it says place an obtuse scaling triangle in a coordinate plane so that way you can assign coordinates to its vertex. Now, this is kind of an arbitrary exercise. What the triangle that you came up with and the triangle that I come up with may or may not be the same. Okay, so here's the coordinates here's the figure that I came up with. Let me go ahead and clean this up just a little bit. So here I said, here's A, which is using the origin, 0, 0. Well, here's point C, so I'm just calling it some length horizontally, C. So that's what this distance is. That is C units long. Okay? Well, because point B does go side to side on the x-axis somewhere, but it goes a different length from here to here, well, you can't really see that. Let me pick a brighter color. So from here to here, that's about B. So that's why I'm saying that's B units long, or M units in this case. Clean that M up. So then from there, it's going up some distance, which we don't know what it is. So I called it N. So point B is MN. Now it is an obtuse triangle that is utilizing the origin and the x-axis to help, and I thought it was a good idea to use the x-axis as the longest side of the obtuse triangle. So, but however you wanted to do it, as long as you were able to identify the fact that because we're going to have 3 distinct coordinates, we really do need to have different variables to represent the same, different horizontal lengths or different vertical lengths. So now taking a look here, we're going back to example 4. Okay, find the length and the midpoint of diagonal AC, and what do you notice? Why should it be the same for all squares? Well, now we're looking at the other diagonal. Because the length of the other diagonal is going to be because it's a square, the length of both of the diagonals is going to be the same. So when you do the distance formula, you're going to wind up with 2 times the square root of s again, and the same coordinates of the midpoint by substituting them into their respective formulas. So for every square that you ever see, those rules will always be applicable. So here we're going to pause at this moment, okay? And so practice the idea of what you're going to be working with midsegments. Remember, midsegment just by itself is it's called a midsegment because it connects midpoints together. And it's in a triangle, it's going to be half as long as the third side of the triangle, and it will be parallel to it as well. And then practice how we're going to be utilizing variables to represent coordinate points for a geometric figure on a plane. Now moving on, like I said, we're going to have a lot of extra vocabulary in this unit, so please, please, please make sure you're paying very close attention to it as we move forward. Even as we go, you might want to think about making flashcards for each unit that we get through or for each section that we go through, and kind of create those as you go. You know, give yourself the name, the vocabulary word, or the vocabulary definition, and a picture of what they look like, so that way you can identify them easily. But anyway, for now, guys, thanks for watching, and talk to you guys soon.